Hey, good afternoon, and welcome to your 1.2 video. So today we're going to be doing the segment addition postulate. And it's something that you've probably been doing all your life, but we're just putting a formal name to it right now. So I want to start off with a word problem. The distance between Morris and Norman, Oklahoma, that's where OU plays, is about 650 miles. So this whole distance here is 650 miles. And if the distance from Morris to Columbia, Missouri is 220 miles, that's where Mizzou is, then I want to know how far is it from Columbia, Missouri to Norman, Oklahoma. I get my labels in there. So the whole thing is 650 miles. The first part of my journey is 220 miles. I want to know how far I have to go here from Columbia to Norman. So what we can do is we can take our total of 650 and subtract our part. Or if I want to put a variable to this, I can say this is X miles. So 220 miles plus X amount of miles, whatever that is going to get me 650. And then what do I need to do now to solve for X? Well, I've got to get X by itself. And if I have a positive 220 here with my X, well, to get rid of a positive 220, I would just take the opposite and subtract 220. So those would reduce to 0, and then I've got 650 minus 220. My final answer would be 430 miles. So this distance here would have to be 430 miles between Columbia and Norman, Oklahoma. And of course, this works for any segment that we see in geometry this year. So we're going to call this the segment addition postulate. And what that is saying is that part of a segment, so PM, part of a segment, plus the other part gets you the whole thing. Or part plus part equals a whole. Nothing really groundbreaking here, but we do need to put some kind of formal definitions into our geometry. So let's do some practice. I want to find DF. And DF is the whole segment. So I'm going to write my segment addition postulate. I'm going to say DE plus EF. So part plus part equals the whole thing DF. And then what is DE? Well, DE is 23. Plus EF is 35 is going to get me DF, the whole thing. So my final answer will be 58. But sometimes, like you see in B, you're not given both parts. Sometimes you're given the whole length. So I can call this missing piece X, and I'm going to write my segment addition postulate. I'm going to say, not D, FG plus GH equals FH. So part plus the other part is going to get me the whole segment. And then we can fill in our values. So what is FG? Well, FG is 21 plus GH is x equals the whole segment length of 36. And like we saw earlier, I want to get x by itself. I want to solve for x. So I need to get rid of this positive 21. I can subtract 21. So 36 minus 21 gets me 15. So the length of GH is 15. All right, now let's try writing the segment addition postulate, and then we'll find our missing lengths. So I'm going to write out my segment addition postulate. I'm going to say SR plus RT gets me ST. So SR, this part, plus RT, the other part, gets me the whole segment length. And then I can fill in the values. So 10 plus 28 gets ST, which is 38 meters. So ST is going to be 38 meters. And now we're given the two parts, but you've got to be very careful. Make sure you read the directions. This says if ST is 5x inches long, find x. Well, okay, that's not going to change our procedure, our process. I'm still going to write out my segment addition postulate. So I'll say SR plus RT equals ST. And we'll just fill in the values. So SR is 8, RT is 12, and ST, they said, is 5x. So what can we do from here? Well, we can simplify this left side. 8 plus 12 is 20, equals 5x, and then we'll just solve for x. So I want to get x by itself. If here I am multiplying by 5, taking 5 times x, well, to get rid of multiplication, I'll do the opposite. I'll divide by 5. And x would be 4. All right, we've got just 2 problems left to do. So here we're going to draw, that's not the color, there we go. Here we're going to draw a diagram for a situation. So we're going to draw a line segment. And it says that point E is between H and W. So I got H, I got W, I'll put E somewhere in here. Doesn't need to be right in the middle. I could put it over here or way over here, but I just put it in the middle. So yours could look different. And it says HE. So where's HE? HE is right here. HE is 3x plus 5. And EW is 5x minus 3. And then they tell us that the whole segment, HW, is 66. So let's write out our segment addition postulate. And I'll do it in blue. Or maybe green. I'll do it in green. So HE plus EW equals HW. And we can fill in our values. 3x plus 5 plus 5x minus 3 equals 66. And now let's just combine like terms. So 3x and 5x gets me 8x 5 and a negative 3 gets me a positive 2 equals 66. And then I can subtract 2. So 8x is 64. And then our last step here, if I'm multiplying by 8, to get rid of that multiplication, I'll do the opposite of multiplication. So I can divide by 8, and x is 8. So I'd like you guys to try this one. You could pause the video and give this a shot, and then when you unpause, I'll do it along with you and you can check your work. So same thing, E is between H and W. HE is 5x plus 5. EW is x minus 9. The whole thing is 32. So if I add my segments together, HE plus EW is 6x minus 4 equals 32. So x would be 6. And if I add 4 to both sides, 6x is 36. Okay, and we have one more thing I want to talk about before you're done. This is our ruler problems. So first thing to notice, we're in centimeters. So between each one of these centimeters, there are 10 marks. So this is 2.1, 2.2, 2.3, 2.4, 2.5, and so on. So you just need to find this length. Well, you can count. There's 1 centimeter, 2 centimeters, 3 centimeters, and then a little bit more here. So ST would be 3, and then let's count. 1, 2, 3, 4. 3.4 centimeters. 1, 2, 3, 4. So ST is 3.4 centimeters. And that's all you need to know for 1.2, just a segment addition postulate. So make sure you're studying for that quiz, and we will see you in class.